This is Alex Hekla. I will be discussing Way ANOVA for Curriculum 7002, Fall 2020, Dr. Murray's class. Mark Twain once said that facts are stubborn, but statistics are pliable. Today we will talk about when to use Way ANOVA. We will define variable types. We will describe steps of the hypothesis testing. We will talk about how to use SPSS with this. We will discuss rejecting or accepting the null hypothesis, and then we will see my references. So when should we use Way ANOVA? We should use it when we are comparing the mean differences between groups with two independent variables. It is also used to find an interaction between the two independent variables. Our variable types. For Way ANOVA, which is also called two-factor ANOVA or factorial ANOVA, we need two independent variables, and they should be nominal. They will often be called factors as well. We will also need one dependent variable, and it should be interval or ratio. And variables each have multiple levels. So for example, we're going to use from the college student data from Morgan et al. 2013. We're going to use gender and marital status for our independent variables. And we're going to use current GPA for a dependent variable. Gender for this situation has male and female, and marital status has single, married, and divorced. Now we will talk about the steps of hypothesis testing. We start by defining the null and alternate hypotheses. We will state our alpha level. We will calculate the degrees of freedom. Then we will state our decision rule, calculate our test statistic, state our results, and then finally state our conclusion. So for our null and alternate hypotheses, we're going to have several, and that's because we have to define the interaction between student gender, marital status, and current GPA, and they all kind of go together. So our first hypothesis, a student's gender affects their current GPA, with the null being a student's gender does not affect their current GPA. Our second hypothesis, a student's marital status affects their current GPA, the null being a student's marital status does not affect their current GPA. And our third is testing the interaction between gender and marital status. So we want to see if the interaction is present, and then if the interaction is not present. For this test, our alpha is going to be 0.05. Other options we could use would be 0.1, 0.01, and 0.001, and that can depend on the degree of specificity required. Obviously, the smaller the number, the higher the degree of specificity would be. Now we're going to start talking about calculating our degrees of freedom. I want to start off by saying SPSS will do all of this for you, but it's probably a good idea that we understand where these numbers come from. So we'll start off by looking at our first variable, which is gender. So lowercase a is the number of levels. So since we have two levels, male and female, our number for a is 2. So the equation 2 minus 1 equals 1. So we have 1 degree of freedom for gender. For marital status, we have 3 levels, single, married, divorced. So for B, we would input 3, and 3 minus 1 is 2. For our DF of marital status times gender, we have A minus 1 quantity times B minus 1 quantity, and that goes to equal 2. Our DF for error, capital N is all of our numbers, and there were 49 acceptable answers, and I'll show that more later. And so we have 49 minus A times B. So 2 times 3 is 6. 49 minus 6 is 43. And then our DF total is our capital N minus 1, so 49 minus 1. It's important to note that all of your DFs should add up to your total. So gender plus marital status times gender plus your error should all add up to your total. So we have 1 plus 2 is 5, plus 43 is 48. Now we need to state our decision rule. Now these numbers come from F tables, and I found mine at UCLA, but you can just type it into Google, type in F tables, and you will be able to find all the F tables. They're all the same. Once you have your numbers for your degrees of freedom, you can put them into an ordered pair like I have here. For gender, it's 1, 43. And you go to your F table and you find your X, which is the first number, and that's the number on the top. So you find 1, and then you go all the way down to 43. Once you hit 30, most of the F tables start to go in bigger intervals instead of just by 1. So I rounded to 40 since that was the closest number I could find. And CV is our critical value. And for 1, 43, it was 4.08. For marital status, it was 2, 43, and our CV was 3.23. And then gender times marital status was 3.23 as well. And the critical value is if the F value that we find when in our calculations exceeds the CV, then we can reject the null hypothesis. If it does not exceed the CV, then we cannot reject the null hypothesis. Calculate test statistics. Fortunately, SPSS does this automatically. However, you can calculate it by hand if you want. You will need the sum of squares for each decision rule. You will need your error and your total. And then you need the DF for each, and you need the mean squares for each. To calculate the sum of squares requires a fair bit of math. It is not hard, but it is quite tedious, and it takes a fair amount of time. I believe that's out of the scope of this presentation. For an in-depth look, you can click on this link and watch a video by Stats Lectures. He goes into great detail about it. Now for SPSS. Once all your data has been entered, or for in this case we're using a preset data, you will click on Analyze, and then General Linear Model, and then Univariate. Your dependent variable in this situation is the student's current GPA. So you would just click on student's current GPA and then click the arrow sign next to dependent variable. For our independent variables or our factors, we click on gender and marital status, and if you shift click or control click, then you can move both of them at once and click the arrow sign. You do not have to do that, you can do them individually. Then you can just click OK to run the basic ANOVA. There are lots of different other options, but that's outside of the scope of this video. Now let's talk about our results. We have now calculated our F sub A, F sub B, and F sub A times B, and we need to compare those values to our critical value values. So our CV for F sub A is 4.08, and our actual or our calculated F sub A is 6.122, so that has exceeded. Our critical value for F sub B is 3.23, and our actual is 7.262, so that is exceeded as well. Then our critical value for F sub A times B is 3.23, and our actual F sub A times B is 0.428, so that is below it. Another thing to note is if you look over in the red circle, you can see all those figures, and then immediately to the right where our sig is, you can see that the first two have met the 0.05 p-value, and the last one has not. So that's another way that you can tell if it is statistically significant or if the null hypothesis should be rejected. Now we state our conclusion. For F sub A, we would reject the null hypothesis. F sub A corresponds with our first hypothesis, so we would reject a student's gender does not affect their current GPA. For F sub B, we would reject the null hypothesis. So we would reject a student's marital status does not affect their current GPA. And for F sub A times B, we would accept the null hypothesis. So There is no interaction between the gender and the marital status. Thank you for watching my presentation today. Here are my references, and I hope you learned something about Way ANOVA.